All right, so today we're gonna get into a little bit of our new chapter in which we're gonna look at logarithms a lot. And so the first thing we need to know is the difference between logarithms and exponentials. And hopefully you saw a little bit of exponentials in Algebra 1. But just a reminder, an exponential is gonna be a function, maybe you have some a coefficient out here, but the main idea is that x is up in the exponent here. That's why they call it an exponential. If you were to say this in English, we'd say y equals a times b to the x. A times b to the x. We want to be able to say it well in English. Okay. And if we were to graph an exponential, um, if it were, let's say, exponential growth, in this case, we have our x and y axis, an exponential, it would look something like this, where it's growing, or if it was exponential decay, it might look something like this. If we were talking about, let's say, some radioactive element was decaying, well, as we go forward in time along our x-axis here, um, that element decays, and so you start to have less and less of this. But you can see that it starts to grow a little bit. It either grows or decays. But the main idea being that you're going to see that x is up in the exponent, okay? Um, Today, what we're going to get into mostly is what's called a logarithm. And so our general form of a logarithm is going to be y equals, okay? And we're going to say, actually, let me back up a second. We are going to say that, there we go, we're going to say log base b of y equals x, okay? Or actually, I'm going to write it the other way here, log base b of y equals x. And I have what I have dubbed the circle method, okay? You guys know that multiplication and division are inverses, okay? Addition and subtraction, they undo each other. Logarithms and exponentials, they undo each other. So another way you could write this is that log base b, if we say we're going to start with the letter down here, b to the x equals y. All right, we're following our circle around b. We start with b, and then we kind of go in a counterclockwise circle. B to the x equals y. Okay. If we wanted to say this statement in English, we want to say it well. We would say log base b. All right, because that's our base down here is b of y equals x. Okay, that's how we'd say it well. And so what we can start to do is we can kind of start to use this idea of being able to rewrite logarithms as exponentials to help us solve a few problems. So the first thing we're going to do, I'm going to kind of move us to a new, I'm just going to slide us down a little bit so you can see that. Let's say, for example, and we'll get a new color here. I said that we have the log base 2 of 16, and that equals 4. Okay. Using our circle method, we're going to start with this little number down here. So we would say 2 to the, and again, we're going to go counterclockwise. 2 to the 4th equals, 16. Okay. Another way you could have looked at it, you could have said, hey, log base 2 of 16 equals 4. We got done saying that logarithms and exponentials undo each other. So if you raise both sides, you say 2 to these powers, you could do that as well. And logarithms and exponentials undo each other. So you'd be left with 16 equals 2. Over here we have 2 to the 4th. Okay, we said 2 to the power of both sides. We're doing the same thing to both sides of the equation. So what we're doing mathematically is legitimate. And as you can see, we get to the exact same place. Okay. Let's try another one. Let's try another one here. Let's say this, in this case, we have log, oh, that's not, let me write. We'll say log base 4 of 1 equals 0. Okay. And you could do this again. We could do it in two ways. You could say way number 1. I remember Mr. Jones said something about a circle method. So we could go with 4 to the 0. We always start with the little number. 4 to the 0 equals 1. Or if you said, oh, hey, I know that logarithms and exponentials undo each other. So when I look at this problem, this is our exact same problem, I'm going to raise both sides to the 4th power. And exponentials, if I haven't, this is really the exponent of 4, this up here, and logarithms undo each other. So I'm left with 1 on the left side, and then I have 4 to the 0th power on the right side. Like, Mr. Jones, is this statement true? Well, yeah, it is. If you think about, hey, what's 4 cubed? 4 cubed is 64. Oops, equals 64. And we're just proving to ourselves that 4 to the 0 is 1. 4 squared is 4 times 4, or 16. 4 to the 1st power, well, that's just 4. And so I want you to notice what's happening to our answer as our exponents are decreasing by 1. Every time our exponent goes 1, we end up dividing by 4. Okay, when we go down this step, we end up dividing by 4. So if I said 4 to the 0, well, that same property applies. We're just going to divide by 4, and we're left with 1. So yes, 4 to anything to the 0th power is 1. You might have remembered that from 5.2 when we talked about that at the beginning of the trimester. Okay. Let's try one more example, and in this case, we're going to write it. We're going to start with an exponential, and we're going to try and write it in logarithm form. So in this case, we're going to say 5 squared equals 25. Okay. And we got done saying that exponentials and logarithms are inverses. So to undo a power, to undo the power, you're just going to have to take the log of both sides. Okay. So I'm going to take log base 5, again, just undoing this power here. So on this side, we're going to be left with 2. And over here, we're going to have log base 5 of 25. Again, you would say that log base 5 of 25. Okay, that's how you would say it in words. Okay, and honestly, that's the main idea. The only other thing you might want to take note of is there's actually a special form of an exponential. Okay, and that number, that exponential, we talked about 2 to the x or 3 to the x. That special form is e to the x. Okay, and mathematicians, they came up with the number e. E is approximately 2.718. And it has some very special properties. If you get into calculus class in a couple of years, you'll see some of those properties. But I want you to just know it's a number. It's kind of like pi. It keeps going on forever. So it's 3.14159 like pi. E is also irrational. It goes on forever like that. And so we just have a special way. Let's say we had said e to the x equals 2, for example. We can take the log of base e of both sides, log base e of both sides, that's an e, okay? And so these would undo each other, and we'd be left with x. And instead of saying log base e, mathematicians have a special way of writing log base e, and that's what's called natural log, and it's abbreviated ln, okay? ln just means natural log. And all it really is, natural log just stands for log base e. So yeah, natural log is a logarithm with base e. It's just a very special one. So if you see that, just don't freak out. E is just a number. Treat it like any other number. And if you're taking the log with base e, it's natural log. Okay. That's about all I have for you guys.